Hey everyone, it's Sanjeev from CodeCloud, and today we're going to take a look at a tool that'll help us manage secrets within Kubernetes. The tool is called External Secrets Operator. And so in this video, what we're going to do is we're going to start off by going over some of the challenges that we face when we work with the default secrets within Kubernetes, some of the limitations, and we'll take a look at why we would want to use a tool like External Secrets Operator to actually manage our secrets. So let's go ahead and get started, and we're going to start off by going over some of the limitations of secrets within Kubernetes. All right, so why do we need External Secrets Operator? So the External Secrets Operator helps us address a couple of different issues that arise with working with secrets by default within Kubernetes. So let's say that we create a secret in Kubernetes, just a plain old generic secret. What happens is Kubernetes will encode the secret for you by default. And a lot of us have a tendency to get this mixed up because we assume that encoded means that it's secure and nobody can read it. Not exactly, right? Usually when you wanted something to be secret, you would need to encrypt it. That means nobody can read it. Encoding does not provide us that functionality. Anybody can decode a secret just as easily as they can encode it. So if you take a secret and then upload it to GitHub, then anybody that has access to that repo will essentially know your database password, because once again, encoding is not the same thing as encryption. So this is the first issue that arises when it comes to working with secrets, right? We need a way to be able to check our configuration into GitHub without exposing our secrets and our passwords to anybody that has access to our repo. Now, the next issue that we might come into is, let's say that we have more than one Kubernetes cluster, and we might be using the same secrets across both of our clusters. And managing your secrets across all of your clusters, right? Imagine instead of just two clusters, you have hundreds of different clusters, and they're all using potentially similar or the same secrets, then we would have to individually go to each one and configure it and manage it and update them and rotate them accordingly. And obviously that's going to be cumbersome. So we would like some ability to be able to sync our secrets across all of our clusters so that we don't have to manually go in and update them one by one. In addition to that, it's very common for organizations to already be using external secret stores to manage their secrets. So things like HashiCorp Vault, AWS Secrets Manager, Google Secrets Manager, and Azure Key Vault. And so since all of our secrets are already being stored and managed by those external software, we need some way to be able to have them sync up with the secrets that exist within our cluster so that our pods and our containers can actually use the secrets that are defined within those external secret stores. And so this is where the External Secrets Operator comes into play. So the whole idea behind it is to help us address some of those issues that I just talked about. So what is the External Secrets Operator? The whole idea behind it is that it's supposed to synchronize secrets from external APIs into your Kubernetes cluster. And so ultimately, it's going to allow you to manage your secrets in a central place like HashiCorp Vault or AWS Secrets Manager, and it's going to allow you to take the secrets that are stored within one of those tools or software and have it sync up with a secret within your Kubernetes cluster. So you're no longer managing your secrets directly within your cluster. Instead, you're defining it within Secrets Manager, and your cluster is going to automatically sync it for you by utilizing the External Secrets Operator. And so since it's going to actually pull in these secrets from the External Secrets Manager, you no longer need to worry about checking your secrets into Git because your secrets aren't actually stored within your Kubernetes manifest. They're stored within AWS or Google or Azure or whichever cloud provider you're ultimately using, and it's going to dynamically pull those in. So you don't have to worry about accidentally checking it into Git. So how exactly does the External Secrets Operator work? To get it up and running in your cluster, the first thing that you have to do is actually install the External Secrets Operator. And we can utilize something like Helm to actually deploy all of the necessary resources within our Kubernetes cluster. So Helm is going to deploy the operator, and it's going to deploy a couple of extra things. It's going to deploy a couple of custom resources, the first one being a secret store. So what is the purpose of a secret store? What is it configuring? What is it actually doing and contributing when it comes to the overall solution? Let's say that we are storing our secrets in AWS Secrets Manager, and it doesn't really matter which service you're ultimately using. You could be using Azure Key Vault. It's the same idea. Our operator and our cluster needs to actually pull in those secrets from AWS. And when it comes to working with any one of these tools or any one of our clouds, we need to be able to provide credentials so that it can actually talk to the cloud, right? Nobody has access to our secrets by default. They have to have explicit permissions, and they need to be able to provide, their access keys and their secret keys. So the secret store is all about configuring and telling your operator how to connect to the secrets manager, what user to use, what credentials to use, so that it can successfully pull in the secrets from AWS Secrets Manager. So when we create a secret store object, it's going to look something like this. And if you take a look at the configuration, it's going to be pretty much exactly what we would expect it to look. So you can see here under provider, we've got AWS, and you can see we've got some extra configuration like what region is our secrets being stored in. You can see here it's US East 1, and then we've got the authorization. So this is going to be a couple of things like the access key information and the secret access key. So that's the credentials to be able to actually talk with AWS. We need to make sure that our operator can actually successfully authenticate with the AWS service so it can pull in those secrets. Now you can see here that there's a secret ref. So it's basically saying that we have to store the access key and a secret access key within a regular Kubernetes secret. And I know there's a lot of secrets that are being involved in this lecture, but now what we have to do is create a plain old Kubernetes secret. And it's going to store the access key and the secret access key. So to do that, we can just run kubectl create secret generic, give the secret some whatever name you'd like. And then you can see here, we pass in the access key and the secret access key. So the access key here is going to reference the key that we provide here, and the secret access key is going to reference the secret access key here. So that's how we pass in the AWS credentials or whatever cloud provider credentials that you're ultimately using. You provide those credentials within the secret store configuration. Now, the next custom resource that gets created by our operator is going to be the external secret. So this is now how we're going to be creating secrets. We're not going to be creating secrets using the regular Kubernetes secrets anymore as users. Instead, we're going to utilize this custom resource called external secrets. And let's say that in our AWS Secrets Manager, we've created a secret within the AWS Secrets Manager, not Kubernetes, but within AWS, we create something called dbcreds, and it's got two key value pairs, the password and the username. So what we want to do is ultimately one of our pods or containers are going to need to have access to those credentials. We create a external secret object. Now, if we take a look at the configuration for the external secret object, the first property I want to go over is the refresh interval. So this is basically going to tell our operator how often to actually query the AWS Secrets Manager for our secret, looking for any changes or anything like that. So every hour, it's going to send a request to the AWS API to retrieve those credentials, just in case there's any kind of update to those credentials. The next thing that we have to specify is which secret store are we using. So this is basically referencing the secret store that we created just a couple seconds ago. So we have to tell this external secret object, what external API are we actually connecting to with what credentials. So you just pass a reference to the name of the secret store that we just created a few seconds ago. And then we have to specify what is the name of the secret within AWS. And so as you can see here, we're going to match a dbcreds with the name of the secret that was created within AWS Secrets Manager. So these two things are going to have to match up. You're just basically telling the external secret object what secret should we look for within AWS. And then finally, we have the target. So the way that the external secret works is once it pulls the secret from AWS, it's going to send a request. It's going to get the dbcreds secret. It's going to actually go ahead and create a secret, a regular Kubernetes secret for you. And the name of that secret that gets created for you automatically is what you specify here. So it's going to be the target. So since I called this kube secret, it's going to create a plain old secret called kube secret. And so this is ultimately what we're trying to get to. At the end of the day, we want a plain old Kubernetes secret that we can then provide as either environment variables into our containers or mount it as a volume. And so this secret that we have can be used just like any other secret. We can pass it in as environment variables or mount it as a volume on any one of our containers. But the great part is this kube secret, it's not going to exist in any of our manifests. And so we don't need to worry about it checking it into Git by accident. We don't have to do that. This is the only thing that's going to be stored within Git, which is the external secret configuration. And you can see here, there's no passwords or anything like that in the configuration. There's no credentials or anything like that. We just provide the name and what is the final name of the secret that should get created. So that's the main gist behind the external secrets operator. It's not too complicated, but let's go ahead and do a demo. And I think once we get through the demo, you guys will see just how easy it is to work with the external secrets operator. All right, so if we go to the external secrets operator page, there's going to be an introduction section where we can select getting started. And this is going to walk us through how to actually install the external secrets operator using Helm. And so this is going to be basically two commands. We're going to do Helm repo add external secrets, and we're going to add that chart repository. And then we're going to install the external secrets chart from that specific repository. And so we could just go ahead and just copy these and run these commands directly in our terminal, and it's going to set that up for us. So I'm going to run that first command. And if I do a Helm repo ls, we should see the external secrets repo. And then we can then go ahead and copy this command. And I'm just going to copy up to here. And this is going to install that chart in a namespace called external secrets. All right, and now we can see that external secrets has been deployed successfully. If I do a helm ls-n external secrets, we'll just make sure that it was successfully deployed, and we can see that the external secrets chart was in fact deployed successfully. Now, what I want to do is, and I don't want to focus too much on this, but let's just take a look at what that chart actually deployed for us. So if I do a kubectl get, I'll just do a get all, and I'll just do a dash namespace, external dash secrets. We'll see everything that was deployed in that specific namespace. So you could see we've got a deployment for external secrets. We've got one for the cert controller, and we've got one for the webhook, and that's going to create the respective replica sets and pods. And we also have a service for communicating with our external secrets webhook. And if I do a kubectl get crd, you'll see the custom resources that were created by the external secrets operator. So there's a whole bunch of them. I don't want to focus too much on that. That's a little bit outside of the scope of this video, but I definitely recommend you guys dive into it and take a look at all the different custom resources that it creates for you. All right, so now that everything's been installed, let's go ahead and configure a secret within the AWS Secrets Manager. So I'm going to go to my AWS console, and I'm going to search for the Secrets Manager service. And I'm going to store a new secret. And here I'm going to say other type of secret. They've got some automatic ones for some of their services like RDS, but this one's going to be utilized by Kubernetes. So here we're going to say other type of secret. And then here we're going to provide all of the key value pairs that we want within our secret. So I'll say db_password, and I'll say this is my password. That's going to be the value of our password. And then the username, the key will be db_username. And we'll say the username is user1. And I'll leave everything else as default. The secret name within AWS Secrets Manager, I'll call this db_, or I'll call it db-credentials. And I will go ahead and hit next. We'll leave off automatic rotation, hit next, and then we will then go ahead and hit store, and that's going to create our secret. If I hit refresh, we should then see db-credentials. And if I click on that, we can see our credentials here. And if you actually want to see the values, you can select to retrieve secret value, and we can see the values here. And if you'd like to, you can also edit it there. So now that we've configured the secret within Secrets Manager, we have to remember that for our external secrets operator to actually be able to retrieve these secrets, we need to give it access to AWS. So we're going to have to give it some credentials, and we need to make sure that it has the necessary permissions to actually read those secrets. So I'm going to create a user for the external secrets operator. So I'm going to go to IAM here, and I'm going to create a user for the external secrets operator, and I'm just going to call this user, say, external secrets operator. I'll hit next. Then we have to give it permissions. So here I can say attach policies directly, and let's see what the default Secrets Manager permissions are. So there's this Secrets Manager read write, and if I take a look at this, we'll basically give it permission to read and write secrets. But keep in mind, our external secrets operator should never need to create secrets, so you don't want to actually give it permissions to both read and write. We just want to give it permissions. So I've already created a policy for that, and here this allows you to list and get secrets. In fact, you could probably even trim it down a little bit further. It probably only needs list secrets and describe secret and probably get secret value. You probably don't need the other ones, but this was just like a default one that I just quickly created. But remember, you always want to make sure that you give only the permissions that it absolutely needs. So I'm going to give it this. This is going to give it read access to technically all of the secrets, which once again, you wouldn't technically want to do. You want to make sure that you drill down as specific as possible and only give it access to the secrets that it should be able to read and not all the secrets like I did here. I'll hit next, and I will then create the user. So now that the user is created, let's select it. And then I'm going to go to security credentials, and I'm going to select create access key. And here I'm just going to say CLI. We just need to just get some basic credentials. I'll just confirm that, and then I'll hit next, and we'll create access key. So now I've got the access key and the secret access key. So if you're following along, just make sure to copy those and just note those down someplace for later reference. And once you're done with that, go ahead and just select done. All right, so we've now got our credentials and all of the permissions set up. And so now we can go ahead and create our secret store, which is going to tell our external secrets operator how to actually communicate with AWS and AWS Secrets Manager. All right, so now I've got this secret store.yaml file, which is going to have a basic configuration for a secret store. I'm just going to walk you through all the configuration. So here under kind, this is going to be kind secret store. So this is the custom resource that comes with our external secrets operator. Give it whatever name you like. I just called it secret store-sample. Then under the specifications, under the provider, since we are using AWS, you just specify AWS. Obviously, if you're using one of the other providers, you would be Azure or GCP or whatever, or Vault or whatever. But I'm using AWS. The service is Secrets Manager. The region that I created that secret in was in US East 1, so I specified that here. And then here, this is going to be all of the authorization configuration. And so here, we're going to need to provide the access key and the secret access key. And there's a couple things that we have to specify. So for the access key, we're going to tell it, where is the access key? How does the external secrets operator get access to it? It's going to be stored in some regular Kubernetes secret, right? This is just a plain secret, nothing special about it. So we're going to have to create a secret. We can call it whatever we'd like. In this case, I'm going to call it AWS SM-secret. And then we have to provide the key in the secret that's going to have the access key. And then we're going to do the same exact thing for the secret access key. And keep in mind, they can be stored in two separate secrets if you'd like, but it makes sense to just keep it in one just to simplify it. But if you did want to, you can put it in a completely different secret. So you're going to specify what's the name of the secret and what key should it look for to get the secret access key. And so those are the two things it needs to be able to connect to the AWS API, authenticate, and properly retrieve those secrets within Secrets Manager. So let's go ahead and create that secret that's going to store all of our access keys and our secret access keys. So I'm going to maximize my terminal, and to create a secret, this is just, remember, once again, a plain old Kubernetes secret. So I'll do kubectl create secret generic, and then we're going to give the name of the secret. And the name is actually important because remember, we specified it within the secret store. It's going to look for a secret called AWS SM-secret. And it's going to look for both the access key and the secret access key within that same secret. And keep in mind, like I mentioned before, they could technically be in two different secrets, but to make it simple, I just put in one secret. And it looks like there's some pasting issues, but AWS SM-secret, and then we can pass in the key value pair. So I'll do --from-literal equals, and then we'll say the first one is going to be the access key. So I'll say access-key equals, and then I stored the access key here, so I'm just going to copy. And then we're going to do the --from-literal again. And this time, this is going to be the secret-access-key, which equals the second value here. I'll run that. We created our secret. If I do kubectl get secret, we could see our AWS SM-secret, which is just a plain opaque secret. And so now everything should be good to go in our secret store configuration. We can actually go ahead and just apply that. So I'll do a kubectl apply -f, and I accidentally hit enter. So I'll say secret store.yaml. And we can see that our secret store was successfully created. Then if you wanted to, you could do kubectl get secret store. And you can also do a describe if you want to see more detailed information. But it looks like everything is good. We can see status valid, ready, true. So now we got everything set up. Now it's just a matter of creating our external secrets. So anytime we need a password or secret that we want to use within one of our pods or containers that's technically stored within AWS Secrets Manager or any other external secret vault of any kind, we're going to create external secrets. Remember, we no longer work with regular secrets, regular Kubernetes secrets. We're always working with the external secrets now. And so to create an external secret, I've got a example config here. We've got here under the kind, it's going to be set to external secret because that's the custom resource. You give it whatever name you want. Here, I just called it example. Then there's going to be a few configurations. So there's the refresh interval. So this is going to be set to 10 minutes and you can customize this however you like. I just set it pretty low just for demonstration purposes. So it's going to send a request to the AWS API to fetch those secrets or this specific secret every 10 minutes. And it's going to look for updates every 10 minutes. The next thing is this secret store ref. So what secret store should it use? What external secret store and what credentials should it use to actually connect to that? And all of that information is going to be stored in the secret store that we just created earlier. So if I take a look at this secret store, you can see the name of it is secret store-sample. And if I go here, we can see secret store dash sample. Then what we want to do is we want to get the data from. So this is basically telling it what specific secret within AWS Secrets Manager should it look for. So we're going to extract a secret called db-credentials. So what is that from? If you guys have forgotten, I'm going to open up my AWS and I'm going to go back to my Secrets Manager. My secret is called db-credentials. So that's why it's referencing that specific key. So this is going to pull in all of the key value pairs from that secret. And then finally, we have the target. So once it pulls in the secrets from here, it's going to store it in a regular Kubernetes secret called kube-secret. You can call it whatever you want. I just called it kube-secret. So we have all the configurations. Let's go ahead and do a kubectl apply -f external secret, and it's going to go ahead and create that external secret. All right, now I'm going to maximize this. And so now I'm going to do a kubectl get, and let's take a look at the external secret. Let's see what we have here. We could see that we have an external secret called example. We could see which secret store that it uses. We could see the refresh interval. And more importantly, we can see the status. And we can see that it's secret synced. That means it was able to successfully pull the secret from AWS Secrets Manager. And we can see that it's ready, set to true. So it looks like it did everything, which means that it should have created a plain old Kubernetes secret for us to actually use and mount within one of our specific containers. So if I do kubectl get secret, you could see that it actually went ahead and created that kube secret. And that name, once again, comes from the configuration that we specified under target. So we called it kube secret here. Then that means that it created this secret here. And so if I do a kubectl get kube-secret -o YAML, and this should be get secret, kube secret, we can see that there's two values, the DB password and the DB username. And so if I just take the DB password and I just do an echo, and I pipe that into base64-d, this is going to decode it, and we can see we got my password. So I was able to successfully retrieve that password from the AWS Secrets Manager. And so at this point, this secret right here, kube secret, it operates just like any other secret that you would have. So you can pass it in as an environment variable into a container. You can also mount it as a volume. It operates no differently than any other secret. Now, before we wrap up this demo, there's one last thing I want to show you guys, and that is I'm going to go back to the AWS console, and what I'm going to do is I'm going to go ahead and change the value of one of those key value pairs. I'll select retrieve secret value, and for the password, I'm going to edit that, and it's going to be my password 2, version 2 of the password. So I made the changes. Now, what do you think is going to happen within the secret here? So if I do a describe again, or do a get secret, we could see this is the value of the DB password. Let's take a look at this, and I'm going to decode this once again. And when we decode it, we can see, oh, wait a minute, what's going on here? It just shows my password, but we updated it. It should show my password 2, not just my password. This is the old password. So why didn't it get updated? It really just comes down to the configuration of our external secret. So we specified here the refresh interval is going to be 10 minutes. So it's going to pull AWS Secrets Manager every 10 minutes in this case. So we're going to have to wait for that 10-minute timer to expire, where it can then, pull the API and get the secret and get the updated database password. So if we wait 10 minutes and run this command again, we should see that the value changed. So I'm going to pause this video. We're going to wait the 10 minutes, and then we're going to double check and just make sure that after the 10 minutes pass, that the password got updated to my password 2. So it's now been 10 minutes, and if I go ahead and run the same command to get the secret, and if I take a look at the secret now for the password, I'm going to once again decode this. We can see that after the 10 minutes, it's now been updated to the new password, which is my password 2. So that just confirms that once the refresh interval expires, after the 10 minutes or whatever value you set, it's going to go and retrieve those secrets from the secret store and then update them accordingly. All right, guys, so that's going to wrap up the video for today. We got a chance to dive into the external secrets operator. We got a chance to see how we can utilize a external secret store like either Vault or AWS Secrets Manager to manage our secrets, and we configured Kubernetes to automatically pull in those secrets when we need to. And so that way we don't need to worry about checking in our secrets into our Git repository accidentally. And so hopefully you guys enjoyed this video. Definitely stay tuned for the next video where we are going to take a look at another tool that we can use to manage secrets within our Kubernetes environment. We're going to take a look at a tool called the CSI Secrets Store. And so that's just another tool that we can use to manage secrets within Kubernetes. Anyways, I'll see you guys in the next video.